All right, so this is what you have on in front of you. This is a foldable note sheet that's going to go in your notebook. So when you fold it up, you're going to see some information, and it's going to be a little unclear probably to see this because of the webcam. So I think once it focuses, you guys will be able to see it better. And if not, what I have for you is there it is, okay? So the very top of your foldable note sheet kind of goes over this definition here, guys. So you want to fill in the part that says a dilation is a transformation that's going to reduce or enlarge your figure, okay? The big thing about dilations, guys, is that you're not going to have congruent figures anymore, okay? Remember congruency was all about like same size, same shape? Okay, these figures are not going to be the same size because you're literally enlarging it or reducing it. We talked about our eyeballs dilating, right, which lets more light in when it's dark out, and then they actually dilate smaller when you get out into the bright sunlight, okay? So guys, in a dilation, you enlarge or reduce it with a center of dilation, okay? That's usually the origin, just like rotations, you rotate around the origin. And then you guys might remember using stuff like, what was it called? COP. Trying to think of what Mr. Polakowski would call it last year. When you did a ratio between two objects, do you remember what that was called? Constant proportionality. Thank you. For some reason, I remember the COP part, but I forgot about the constant, okay? Scale factor is just like that, okay? It's the ratio that you look at between the corresponding sides of the shape. So just like the little Matchbox cars that you guys used with Mr. P last year, and you looked at the ratio between the Matchbox car and the real car, all right, it's proportional. Okay, so when we're in 8th grade and we're working with dilations, we know that we have figures that are proportional to each other. Okay, is there anybody who needs more time on this top part? No. All right, so next slide, okay? This is how we calculate that scale factor, guys, okay? We multiply by a certain amount, okay? That scale factor, a lot of times they use the letter K. So right here in the bottom part of your note sheet, you're going to fill in that any points when you're doing a dilation, it's going to get multiplied by K, that scale factor. All right, so K times X, K times Y is how you figure out where your new points are going to go. Now keep in mind, if you have a scale factor that's between 0 and 1, like it's a fractional value, what happens when you multiply by a fraction? If I take half of something or a third of something, doesn't it get smaller? Yeah. What happens if I multiply by something that's more than 1? If I multiply by 2 or 3 or 4? It gets bigger, okay? So that's how you know if you're going to get a reduction or an enlargement. Anybody have questions or need more time on this? Okay. So guys, your first problem that you're going to do if you pull up this next flap, all right, is you've got this image that somebody already drew for you. And what I always tell students to do, you're on this flap right here where it says example 1, right? What I always tell students to do is when you have to do a dilation, you really need to write down the coordinates. Okay, so let me put it back on this screen so you can see it better. The coordinates to that shape right there are 1, 0, 3, 3, and 3, 1. So right now, guys, we're looking at the initial shape that was graphed on the paper for us, okay? They didn't write down the coordinates, but they really should have. Because when you're doing scale factor, when you're doing a dilation, in this case, we need to dilate by 4. That's going to make the shape 4 times bigger than it currently is, all right? So if your scale factor is 4, remember we use the letter K to talk about scale factor, we need to take our points and we need to multiply both parts of the points by 4. The X's and the Y's get multiplied by 4. So guys, your point that used to be at 1, 0, what happens when you multiply that by 4? 4 times 1 is 4, right? Be careful, what's 4 times 0? Still 0. So that means your image for A prime is going to be way over here instead. Okay? It's 4 times farther away than it was. What happens when you multiply 3, 3 by 4? Yeah, you're going to have to plot this point at 12, 12. So 4, 5, 6, 7, 8, 9, 10, 1, or 11, 12 takes you out here, doesn't it? 4, 5, 6, 7, 8, 9, 10, 11, 12. Luckily, our grid is big enough, right? The image point for B prime is way out there. And then what about C when I multiply both parts by 4? 4 times 3 is 12. 4 times 1 is 4. So where's the point 12 for? Right here. What do you notice about your image? It's huge. It's 4 times bigger, right? That's what happens with a dilation when you're enlarging, when you're multiplying it by 4. Okay? Any issues, any questions? Go ahead and take a look at the bottom one now. Okay, what you're going to do is you're going to write down the coordinates. And again, it's very blurry, so let me use my screen here. I want you to look at those coordinates. That's still example 1, sorry. There's example 2, okay? When you look at those coordinates, okay, the original shape is over here. It looks like I used red on the original shape for this one. So if I just highlight this, you're going to see there's the original shape. There's the point -1, 0, 1, -2, -1, -4, and then -2, -3. But what they did in this example, instead of having us do the dilation, they showed the dilation right on the paper. So if the dilation's already done for you, it's a good idea to write down those coordinates as well. So that's why I put A prime is over here, -3, 0. B prime is over here at 3, -6. -3, -12, I think that is. And then -6, -9 is your next point. All right? So having those points side by side, how does that help us? Because in this question, they wanted us to find the scale factor. What can you do between the coordinates? Obviously, it got bigger, so our scale factor is more than 1. But how do we know exactly what the scale factor is? We could, yeah. Okay, I always like to look at it like, what did I multiply by? What did I do to get from here to here? What did I do to get from here to here? Okay, or you could go backwards and say, hey, what happened when it was a -1 and now it's a -3? Do you see anything similar with those coordinates? They did what, Sophie? Exactly, okay? If you take every one of these values and you multiply them by 3, you end up with these points, don't you? So you guys just figured out what the scale factor was. They did 3 times the x's. They did 3 times the y, which makes your scale factor exactly 3. Okay, they don't usually use weird numbers when you're doing these, guys. It's usually pretty straightforward. Either they doubled it, or they tripled it, or they multiplied it by 5, okay? Usually they don't do anything really strange like 1.6, okay? But you could. You could enlarge it 1.6 times as big as the old one if you really wanted to, okay? So any issues with example 1 or 2? Okay, that's a big portion of your note sheet, yes? All right, take a second, finish getting those down, because I know there's a lot to write on there. I'm just going to pause this so that it is. What we have with example 3 is an example of where we're going to reduce the size of our given image. The image is pretty big. It takes up a lot of space on our grid. If we want to reduce it, this one tells us we're going to do so with a factor of 1/3. Remember what happens when you multiply something by 1/3? You're really dividing by 3, aren't you? So we're going to make our image to be 1/3 the size it originally was. So what you should have down on your paper, guys, are the coordinates of the image that they gave us. And what's nice about this problem, all the numbers that we have to deal with, aren't they all divisible by 3, so we won't end up with any decimals? Okay, that's the nice part about this one, especially since we have a scale factor of 1/3. Remember, K is what we use sometimes to talk about scale factor, okay? So that's why I wrote K equals 1/3. I also wrote this reminder. You're going to take 1/3 times the x's, 1/3 times the y. But taking 1/3 of something is just like dividing by 3. So what happens when you take 0 divided by 3? Still get 0, but what's 12 divided by 3? right? What's 9 divided by 3? Okay, so this point's going to be 3, 3. 12 divided by 3 again is 4. 6 divided by 3 is 2. 3 divided by 3. So that point's going to be at 1, 1, isn't it? Okay, so guys, what is your image going to look like when we get this plotted? It's going to be really small. Here's the point 0, 4. That's A prime. Label it. 3, 3. Okay, it happens to land where the other point used to be, all right? But in a minute, you'll see why that works out. 4, 2, and 1, 1. Did your shape obviously get smaller? Yes. Okay, but let's talk about the actual shape. It just looks like a miniature version, doesn't it? Okay, that's why we said that dilations create similar figures. Similar means it's the same shape, but it's a different size. Okay, very different from congruency. Congruency kept the size and the shape the same. So we got to know about similar things, okay? And these are definitely similar. It looks like somebody just shrunk it right down, okay? And it got closer to the origin, right? Because we said the origin is your center of dilation. So if you're good, your shape should be the same, but it looks like a little miniature version. How do we do? Got it? All right. So the last one in this little packet, I believe they gave us both images, didn't they? Yeah, so the little one, it looks like I used red ink. Oh, the little one is the image. Be careful. Look at the labeling. A, B, C is the original shape, guys. And then the image is this one right here because it's labeled A prime, B prime, C prime, okay? So make sure you look carefully. I almost got that backwards, okay? So the original image is pretty big. Look at the coordinates. You've got a point that's at -5 up 10. You've got a point that's over at 5, 0. And you've got a point that's over at -5, -5, right? So look at the numbers that we're dealing with for the image. A prime was like way down here. There's B prime, there's C prime. Okay, it's definitely a reduction because the shape got shrunken, all right, or reduced. What do you see about the pattern? If you divide every one of these by 5, okay? So how do we write that up as a scale factor, though, guys? Because we can't really use divide sign 5. We have to use some kind of numerical value. 1/5, very good. Okay, if you use 1/5 as your factor, that's exactly the same as saying you divided by 5. So instead of k there, we want 1/5 times the x. We want 1/5 times the y. And that means our actual scale factor is 1/5. Very good. Okay, if you recognize what the pattern is, you just have to write it up as a fraction when you're doing these.